Today we're going to be looking at how to balance chemical reactions. And so in order to be able to balance a chemical reaction, the first thing we have to do is be able to write the proper chemical equation for a given reaction. So we're going to use the one you see here where we have hydrogen gas reacting with oxygen gas to produce water. So when we write that, we have our hydrogen gas, which as we know is H2 because it's diatomic, and we're going to react that with oxygen gas. So when some things are reacting together, we're going to use that plus sign to show that they're going to react together. And instead of using an equal sign to give us our products, we're going to draw an arrow. And so here we're going to draw our arrow to show that we're going to produce H2O. So we have these two, H2 and O2, are reactants. Then we have our H2O, which are our products. Now, one thing as you can see is obvious here is that we have to keep in mind, really, the law of conservation of mass and Dalton's atomic theory, right? So both of those things tell us that mass have to be conserved, and Dalton's atomic theory, more importantly, tells us that in order to do that, we cannot create nor destroy atoms, right? They can just be rearranged. But obviously, if we look here, it appears that we've lost an oxygen atom because we have two on the left side and only one on the right side. So the easiest way to remedy that situation in this case is like, okay, well, Mr. Lambert, we've lost it. Why can't I just put a 2 right here as a subscript on there? That would make sense, right? We just mash them together. Well, if we put a 2 there, what we've done is changed the formula. And so we no longer have water, which we know is H2O. Now we have something called hydrogen peroxide, which is a lot different than water. You really wouldn't want to drink it. And so adding subscripts is bad. We cannot do that. So we have to be able to do something else. And so if we look at this and we say, okay, we have our H2 plus our O2, and we're going to go to our H2O, then what do we need to do and how can we do that? Well, as you can see, right, we have our hydrogen here, right? We have our oxygen here. Oh, there's our water. And we have our oxygen here. And so this is a great visual representation for us so we can see what's going on. And if we count these atoms of hydrogen, it's pretty clear that we have 1, 2 there, and we have 1, 2 here. We have 1, 2 oxygens, but we only have 1 oxygen here. So what's the problem? What are we going to do? Well, a lot of times when you have a chemical reaction, you don't just have one of each thing. And so sometimes you need to have 2 or 3 or 4 of those things in order for that chemical reaction to go. And so in this case here, what we see is, well, it looks like we have enough oxygens or hydrogens. We don't have enough oxygens. And so in order to get enough oxygen so that we don't have this go, what we're really going to have to do is we're going to have to create a second water molecule. So in this reaction, we actually don't just create one water molecule, we create 2. But hopefully you can see now, you're like, well, Mr. Lambert, if we're creating 2, then we don't have enough hydrogens. Well, in order for this reaction to work, we would actually need another hydrogen molecule. So we would need 2 of those to react with only 1 oxygen molecule, and that's how we're going to get this. So then how do we show that in our chemical reactions? Well, this is where we can show using our subscripts, or I'm sorry, not our subscripts, our coefficients. Do not use subscripts. We're going to use our coefficients, where we can say, okay, well, we had 2 of those, and we need 2 of those. And so now we can see and we can show how many we actually need for the chemical reaction to happen through the use of those coefficients. And so this right here would be our balanced chemical equation for the production of water from H2 and O2. So let's see how this goes into play when we practice it with some other chemical reactions. So now we look here, we have our potassium chlorate. It's going to go to potassium chloride plus oxygen gas. And so in order to balance this, what I'm going to recommend you do all the time is start over here on the left. And when you start on the left, then you're going to kind of go atom by atom. And so I'm going to look, I have 1K over here, I have 1K here. I have 1 Cl, I have 1 Cl. And here I have 3 oxygens, and over here I have 2 oxygens. So this is obviously not balanced, so what do we got to do? Well, when we have a situation when we have an even number on one side and an odd number on the other, I'm going to ask you to double the odd number. So in that case, I have to double this. I'm going to put a 2 out front. And so now that kind of changes this to go, okay, now we have 2 of those, we have 2 of those, and we have 2 times 3 or 6 oxygens. So if I do that here, well, if I have 2K here, now I only have 1, so I need to put a 2 there. That's going to give me 2 here and 2 here. And then I say, okay, well, I have my 6 oxygens. Here I only have 2, so now I can throw my 3 out there because I know that 3 times 2 is 6 because I learned my multiplication tables. And so now we can look and like, ooh, cool. I have just balanced this equation where I'm going to have 2, 2, and 3 in order for that to be balanced. All right. Now, let's look at something a little bit different. So now we have a different chemical reaction. And this particular chemical reaction looks the same, but we have 2 reactants and 2 products. And more importantly, oxygen is spread across both of our products. How do we handle that? And how do we do that? And so, but again, we're just going to attack it in the same way. So if I start over here, I'm going to start with my C's. I have 4 C's here. I only have 1 here. And so if I put a 4 there, then that changes that to 4 C's. I have 8 hydrogens here. Over here, I only have 2. So if I put a 4 there, then I'm going to have 8 hydrogens. That's all fine and good. Here I have 2 oxygens. But now on this side, I have, okay, well then I have 4 times 2. That's going to give me 8 oxygens here, plus now I have 4 times 1, and so then I also have 4 oxygens here, so grand whopping total on this side of 12 oxygen atoms, right? So now I have 12 oxygen atoms on this side. I only have 2 on this side, so if I try to get 12, I learned long ago that 6 times 2 equals my 12 that I need. And so now if I go back, I always check once I change something. I have 4 carbons, I have 4 carbons, I have 8 hydrogens, I have 8 hydrogens, 12 oxygens, and I still have my 12 oxygens. So now when I do that, that is balanced. All right, now for the fun part. Now what happens if I have words? So a solution of aluminum sulfate is reacted with a solution of potassium hydroxide to form solid aluminum hydroxide and a solution of potassium sulfate. So now I have this, and I have to translate this sentence into formulas, into an equation. And this is where it's going to be really important for you guys to be able to write the proper chemical equation in order to make this happen. And so again, if we go back to basics, I have aluminum. Aluminum's in group 13, so that's going to be +3. I have sulfate, and I have sulfate I know is SO4. That's going to be -2. Then I have potassium. Potassium is going to be K+, because it's in group 1. I have hydroxide, and I remember hydroxide because it's a polyatomic ion. It's going to be OH-. Then I have aluminum again, 3+, hydroxide, OH-. Potassium K+, and sulfate SO4 2-. So if I go and write this out, remember I have to crisscross the charges, so I'm going to get Al2SO4 in parentheses 3 plus my KOH, and that's going to give me my AlOH3 plus my K2SO4. Now, if I look at this, you guys may be like, oh my goodness, I have oxygens all over the place. What's going on? How is this going to be? This is going to be really hard to balance. The good thing is if we look at this, one thing that we should notice is that we're dealing with polyatomic ions. And what I see is that my polyatomic ions stay the same on both sides of the equation. They don't get broken down, they're the same. And so when I'm balancing this, instead of balancing each individual atom, what I can do is balance my polyatomic ions since they're still functioning as a group. And that makes our lives a little bit easier. So again, if I go back to here, if I start over on this side here, I see, okay, I have 2 aluminum here. I only have 1 over here. And so I need to put a 2. And that gives me that 2. Now I go here, I have 3 sulfates. Here, I only have 1 sulfate here, so I can put a 3, and that would give me 3 of those sulfates. Now I go to potassium. Potassium, I have 1 here. Over here, I have 3 times 2, which is 6. And so I would need a 6 there. And if I look at my hydroxide, I have 6 hydroxides here. And lo and behold, 2 times 3 would give me my 6 hydroxides here. So now I got my balanced equation where I would have my Al2SO4 3 plus 6 KOH going to 2 AlOH 3 plus 3 K2SO4 for my final balanced equation. All right, guys. I want you guys to work these problems, the book problems that are on the topics, to get some practice with this. I will put solutions up as videos tomorrow once everybody has submitted. And again, I'll be available during office hours today, so feel free to call and ask questions if you didn't understand any of this. All right, peace, love, happiness. I hope you have a great day. Talk to you later.